Welcome to Abstract Bytes. Today, we're diving into a problem that has haunted the software world for decades. Why is it that huge, important projects so often go completely off the rails? Well, the answer might come from an idea that's nearly 50 years old, but believe me, it is more relevant than ever. So the heart of this whole thing was nailed down ages ago by Frederick P. Brooks Jr. in his incredible book, The Mythical Man-Month. He dropped this bombshell of a quote: "Adding manpower to a late software project makes it later." Now, that sounds completely backwards, doesn't it? It flies in the face of everything we think we know about getting a big job done. And that's the big puzzle we're going to unpack right now. Why on earth does this happen? And if just throwing more engineers at a problem is like trying to put out a fire with gasoline, what's the real alternative? What actually works? Okay, so to get this, you have to understand that not all work is the same. Brooks breaks it down into two basic types. First, you've got what he calls a partitionable task. A perfect example is picking cotton. You add more workers, you get more cotton picked. Simple. The work divides up easily, and people don't really need to talk to each other to get it done. But software? Oh, software is a completely different beast. It's a systems task. You're not just producing individual units of stuff, you're building one single complex, interconnected machine. And the one thing that defines it, the crucial difference, is communication. Every single component has to know what the other components are doing. They all have to fit together perfectly. And this is where the trouble starts. This is the direct result of that intense need for coordination. You see, when you add more people to a software team, the number of communication pathways, the number of potential conversations and misunderstandings, it doesn't just grow. It absolutely explodes. And the math behind this is just brutal. The communication effort ramps up according to the formula n times n-1, divided by 2. Now, you don't have to be a math whiz to see what's happening here. What starts as a tiny bit of overhead for coordination quickly balloons and starts to dominate everything else. Pretty soon, your team is spending more time trying to stay in sync than actually building the software. And that is what makes a late project even later. So if the problem is basically too many cooks in the kitchen creating communication chaos, what's the solution? Well, the book introduces this fascinating idea from a guy named Harlan Mills. He contrasts two ways of thinking about a team. The standard approach is like hog-butchering, where a bunch of people are all hacking away at the same problem. The alternative? The surgical team, where you amplify the skills of one brilliant expert with a dedicated support crew. So let's meet the star of this show, the surgeon. This isn't your typical tech lead or manager who just delegates tasks. No, this is the master craftsman, the chief programmer who is so good that they personally define the problem, design the solution, write the code, and test the core of the system. The entire system's vision is held inside this one person's head.
But here's the magic. The surgeon is not alone. They're backed by a team of specialists whose only job is to make the surgeon faster and more effective. You've got the copilot, who's the surgeon's equal, a sounding board for ideas and a backup. You've got the toolsmith, who builds whatever custom utilities the surgeon needs. The tester plays the role of a friendly adversary, constantly trying to break the surgeon's code. The editor handles all the documentation, and the administrator deals with all the bureaucracy, personnel, budgets, you name it, so the surgeon can stay 100% focused on the technical work.
Now, look at what this structure does to that communication problem we talked about. It's a night and day difference. On a typical 10-person team, you have this tangled, chaotic web of interactions. It's a mess. But on a surgical team, that web is totally simplified. Most communication flows directly through the surgeon, cutting out almost all of that wasteful overhead. So what's the ultimate payoff for this radical structure? What does it actually get you? Well, it achieves something Brooks calls conceptual integrity. He argues this is the most important thing in system design. It's the idea that an entire system should feel like it was designed by a single, coherent mind. And that's the secret sauce. The surgical team model ensures the system is the product of one mind, or maybe two at the most, working so closely they act uno animo, as one. And because of that, the final product is simpler. It's more elegant. It's easier for people to use because there aren't a dozen different design philosophies all bolted together. It has a unity that makes it powerful. Which brings us to a really interesting question for today, right? This book was written back in 1975. We now live in an age of agile methodologies, Scrum, and these very democratic, collaborative teams. So looking back, is this whole surgical team idea just an outdated, aristocratic fantasy? Or is it a timeless, fundamental insight into what it really takes to build great things? That's something to think about.